And we will have Véronique, which is my pleasure to introduce Véronique from ANSES, and will present the third total diet survey. So for the story, we work a lot with Véronique. She is also one of my PhD students, so another one. I have two in this room, nice. So I started alone the first total diet survey in France, and the second one was coordinated by me on Véronique, and the third one is now under the hand of Véronique. So Véronique, the floor is yours now.
Thank you very much. Hello everybody. I would like to thank the BFR and WHO for giving me the opportunity to present you today the general outlines of the French total diet studies. So I will divide my talk into three main parts. First, I will tell you about the history of the TDS in France and their implementation. Then I will present you some general results of the total diet studies, and then I will explain you why we need total diet studies in France and what we are going to do with the results. So let's talk about the history of the total diet studies in France. As Jean-Charles said, in France we have implemented for the moment 3 total diet studies. The first one between 2001 and 2005. It was conducted by the National Institute for Agronomical Research with the help of the French Food Safety Agency. It targeted the general population, I mean adults and children over 3 years of age. And in this TDS, we focused only on around 40 chemicals, mainly nutrients, minerals, trace elements, and mycotoxin, for a general budget of around 1 million euros. So in 2006, we decided to launch a new total diet study, the second French total diet study. So again, it was on the general population, adults and children over 3. It was based on our national consumption survey, the so-called survey ANCA. ANCA 1 for the first CDS, ANCA 2 for the second TDS, and now ANCA 3 for the third French total diet study. In the second TDS, we focused on a larger variety of chemicals, and I will go back on the chemical family in a couple of slides. And as you can see, also the budget was larger, higher, mainly because of the variety of analysis. In 2010, we decided to launch a new total diet study, but this time focusing on infants and children under 3 years of age. So why this TDS? Because this specific population was not included in the previous total diet studies, because this population was not included in the national consumption surveys. The national consumption surveys only started at 3 years of age. So at this time, we hadn't specific consumption data for this population. And another specificity is that infants and young children are with particular high concern because their exposure is higher than adults because of a high ratio between the total amount consumed and their low body weight. And then in 2019, we began with our new total diet study on the general population, again, adults and children over 3 years of age. So this third total diet study is based on the National Consumption Survey ANCA 3, the new one, the new data. And in this survey, we plan to analyze at least 250 chemicals, but certainly more because of the multi-chemical analysis. Yeah. I won't go into detail in all the chemicals we analyzed in our last total diet study, the second one on the general population and the infant total diet study. But here on this slide, you have a general overview of the different families we analyzed. So as you can see, we analyzed different families from different origin and sometimes from mixed origin. We have natural chemicals such as mycotoxin, mineral, trace elements, and so on. We also have contaminants mainly coming from human activities, such as the persistent organic pollutants, I mean dioxin, PCBs, perfluorinated compounds, and so on. We also have heat-induced contaminants, such as acrylamide or furan. And we also analyzed contaminants or chemicals that are not only environmental contaminants, but that are also added intentionally at a specific step of the food chain, such as pesticide residues or food additives also. Now I would like to present you some specificities of our third total diet study, the ongoing French total diet study. First of all, regarding the sampling, each sample of this new total diet study is made of 12 subsamples. So why 12? It comes from the work of the European project TDS Exposure, in which specifically the BFR work has shown that 12 subsamples was a good compromise between the need to be representative of the contamination of the food and compromise also with the cost of all the products you have to buy for your TDS. Another specificity of this total diet study is that, contrary to the second total diet study, we decided this time to have no regional stratification of our sampling, because by analyzing the results of the second total diet study, we only noticed a few differences, few significant differences in the contamination and in the exposure of the population between the different regions. So we decided this time to save money, also not to stratify on the regions, but we decided, however, to cover 3 different regions of France, as you can see on this map, for the sampling. So another specificity is that we consider the seasonality in the sampling, the seasonality of consumption, and the expected seasonality in contamination. So I mean that, like in the TDS Luc presented, we have mainly 2 seasons for our samples. So the seasons were decided according to the consumption of the foods, but also, as I said, regarding the expected difference in contamination of the foods. So we have 3 different types of samples, samples that are collected on 12 months for foods for which we did not expect any high difference in contamination on the year. And we have seasonal samples for foods for which we expect differences. So the samples are collected on 1 or 2 3-month period, and also for some specific foods on a 3-month periods for very, very specific seasonal consumptions, such as cherries and so on. Another point for this third TDS, last but not least specificity, we decided this time to have a stratification according to the agriculture type. I mean, we have this time foods from conventional food and organic food samples. So our idea is not to make some comparison in contamination level between organic and conventional food, because we won't have enough data to be statistically robust. But our objective is to take into account in exposure scenario the fact that French consumer can eat organic or conventional food in their diet. So, as I said, this new total diet study is based on the last National Consumption Survey, ANCA 3. So, let me present you this new survey. It was conducted between 2014 and 2015 on a sample of almost 6,000 individuals living in mainland France, adults and children. So the data were collected on more than 1 year to take into account the seasonality of the consumption and the consumption specific for some events such as Christmas, for example. And on a subsample of around 4,000 individuals, we had a collection of detailed data on individual food consumption, I mean foods and beverages, including water, with a predefined and standardized detail level, so the so-called facet and descriptor system. And I will go back on this system in a couple of slides. So the system allowed us to catch the very detailed characteristics of the food consumed by the population. The data collection was made based on 2 or 3 non-consecutive days, 2 weekdays and a day of weekend, according to the recommendation of the EFSA, through 24-hour recalls for the adults and the oldest adolescents, and 24-hour records for children and the youngest adolescents to avoid from memory bias. These 24-hour recalls or records were completed by also a long-term food potency questionnaire on a limited number of food items or food groups. So now let's talk about the selection of the foods to be collected in our sampling. It is based on 3 main steps. The first step is from the National Food Consumption Survey to group together all the food items that are considered to be similar from a contamination point of view. As an example, we grouped together all the chocolate bars with coconut, with almonds, with other nuts, and so on. We grouped all those food items into a so-called chocolate bar TDS item. Then in the TDS item, we selected the most consumed foods by the population, I mean adults and children, separately, and with at least consumer rates of 5%. And then to this list, in a third step, we added the foods that were not highly consumed by the population, but that are known or supposed to be high contributor to the exposure. Just some example, we added liver, which is not highly consumed in the French population, but that can contribute a lot to the exposure to some trace elements, or lemon, for example, for the pesticide exposure contribution. And with this step-by-step method, we reach a total number of food items for this new total diet study of 275, and that allowed us to cover more than 90% of the total diet of our population. And as you can see on this figure, this is the diet coverage by the sampling for the different food groups. So I'm sorry it's a bit little, but the idea is that for almost all food groups, we managed to reach a coverage of more than 90% for adults and children, and there is some exception. For example, for the fish dishes, the coverage is a bit less, but that can be explained by the fact that for those groups, for example, for fish dishes, this is a very little group with a limited number of food items, and if we would like to reach 90 or 99%, we should have to add to our sampling food items that are consumed by a very, very low number of consumers in our consumption survey. So we decided not to include other foods. So once we have our food list, we have to build our sampling plan. We have to identify all the subsamples that have to be collected. And to do that, we analyzed all the characteristics of the foods that are consumed by the population, and we allocated all those characteristics to be representative of the consumption to all the subsamples of each sample. So this is all the characteristics that we take into account usually in our total diet studies. So the food process or texture of the foods consumed, the flavors or fragrances, for example, for the yogurts, or the varieties of the different fruit and vegetable. We also take into account the place of purchase that are mainly visited by the consumers. Do they go preferentially to the supermarket, market, retail outlet, and so on. We also take into account the storage method of the foods, fresh, frozen, and so on. We take into account the brands purchased by the population on the basis of the market shares of the product. And then we take into account the preparation methods and the cooking methods, including the utensils that are used by the population to cook. So I would like to say a bit more about the facet descriptor system. I don't know if you are familiar with it. As I said, this system allowed us to catch all the diversity of the characteristics of the foods consumed by our population. So I will show you an example. So the data were collected through telephone interviews and using the Global Diet software, which was developed by the IARC. So this is an example. It's maybe a little, but it's not important. And I'm sorry, it's in French, but it is not important too. So here we are on a record of an individual. This is the lunch, and he declared to consume a plain yogurt. So this interviewer was asked about the source of the milk of the yogurt he consumed. Was it from cow milk? Was it from goat milk, oat milk, and so on? Then he was asked about the type of production of this yogurt. Was it homemade? Was it provided by an industrial, and so on? Then he was asked about the packaging of the yogurt in glass, plastic, cardboard, and so on. Then he was asked about the brand of the yogurt. Then he was asked about the department where he purchased this yogurt. Then, to finish, he was asked about the sugar content and the fat content of this yogurt. And with all this information collected, we are able to identify precisely which type of yogurt was eaten. So we have the facet descriptor. All the facets are all the characteristics, the different characteristics, the different questions asked for each food, and the descriptors are all the possible answers to all questions. We have something like 25 different facets in the consumption survey. As you can imagine, all the facets are not asked for all foods, only the relevant one. But as you can see, it can be long. It's long for each interview. It's long to answer to all the questions. It's very long. And as you can imagine, we are working on how to reduce this time and the number of questions to make it easier and faster for our next consumption survey. So I won't go into detail, but this is just an overview of all the data sources we used to build our sampling plan. So as I said, most of the information came from our national consumption survey, but not only, even if we have a lot of information, we needed other data. So we used data from the Kantar Household Consumer Panel, especially on the different, on the market shares of the different brands. We also used data from a public interest group, the French Agency for Development and Promotion of Organic Agriculture. This organization published every year data on statistics on the sales and production of organic foods in France. We also use data from specialized trade media, National Establishment of Agricultural Seafood Products, and from the Observatory of Food from ANSES. So now I will present you some main results of our total diet studies. So only the second one and the infant total diet study, as the third total diet study is still ongoing. So what we learned from our total diet studies, out of more than 300 substances or chemical families that were evaluated, I mean for which we add an health-based guidance value to assess the risk. As you can see on this figure, for most of the chemicals, the risk was considered to be acceptable or tolerable regarding to the health-based guidance values. So I won't go into detail in those results or this list of chemicals for which we concluded that there was no risk. I just want to underline that the agency concluded that even if there is no risk for the moment for those chemicals, we recommend to keep the surveillance to confirm those results and also to maintain the effort on the reduction of food contamination. And also we recommended to reassess some health-based guidance values regarding new toxicological effects and especially new effects such as endocrine disruption. And some of the health-based guidance values of some of those chemicals have been revised since those total diet studies. Now, for a limited number of chemicals, we concluded that the risk cannot be ruled out, or the situation is identified as a concern for this limited number of substances. This is the chemicals identified in the infant total diet study, so with a risk for the infant or young children. But actually, for 9 chemicals, the conclusion was common to the second total diet study, so for older children and for adults. So that concerned mainly metals, inorganic arsenic, lead, aluminium, cadmium, methylmercury, dioxin and PCBs, but also some mycotoxins, such as dioxinivalenol and its derivatives, but also acrylamide. So for those chemicals, we recommended, of course, to try to lower the exposure. So how to lower the exposure? The agency provided recommendations regarding a lowering of the concentrations, or also dietary recommendations. I won't go into detail. This is just some examples of the recommendations of the agency following the total diet studies. So we proposed some actions to lower the concentration, for example, for acrylamide. We also proposed to revise or to set up a new regulation for some compounds that were not regulated, acrylamide, furan, inorganic arsenic, which is only regulated in drinking water, some mycotoxin and so on. We also proposed to work to determine the possible ways of action, the lever of action to try to reduce the exposure, for example, for cadmium, because in France we have a high exposure to cadmium. And we also propose to establish consumption recommendation, or we remind the consumption recommendations, especially for fish consumption, to lower the exposure to methylmercury and PCBs. Our total diet studies also allowed us to identify some at-risk practices. I just show you one example coming from our infant total diet study. In this study, we realized that 14% of the children consumed common co-milk before the age of 1. So common co-milk and not infant formulae or follow-on formulae. And this consumption lead to a total exposure to dioxin, furan, and non-dioxin-like PCBs higher for those children than for children consuming infant formulae. And also, as you can see on this figure for the different age classes. And this consumption also lead to an exceedance of the calcium upper safety level. So these results led us to conclude and to remind this general recommendation from ANSES that in the absence of breastfeeding, young children should only consume infant formulas and follow-on formulas approved in health regulation and not common co-milk. So I wanted also to underline that our total diet studies reinforce the need to face some analytical challenges. So this is that follow some discussions we had also yesterday. So this is just an example with the results of the pesticide residues in the second French TDS. So out of a lot, hundreds of pesticide we analyzed in this survey, we had a high rate of censored data. I mean more than 60%, and for some chemicals until 100% of censored data. And as you can imagine, we managed the censorship following the recommendations of WHO by calculating a lower bound exposure and an upper bound exposure. So under the lower bound exposure for non-detect results, under the lower bound exposure, we considered the contamination was 0, so the exposure of the consumer was also 0. But under the upper bound scenario, we considered that all the results non-detect were at the LOD. So for a limited number of chemicals, the exposure was 0 under the lower bound approach and exceeded the health-based guidance value under the upper bound approach. So in this case, we were not able to conclude to the risk regarding those 9 chemicals, 9 pesticide residues. So that underline the need to lower the analytical limits to meet the needs of the risk assessment. So this was the result of the second total diet studies, and in the next one, in the infant total diet study, we succeeded in lower the analytical limits for some of those pesticides. But actually, as a lot of health-based guidance values are revised, and most of the time they are lowered, so we again and again we have this problem, and we have for some chemicals to try to lower the analytical limits. This is a big challenge of total diet study to reach the needs of the risk assessment. So my last part will be on how we use the results of the total diet studies. So I just want to show you some examples of use of the results apart from risk assessment and communication to our risk managers. The results of the total diet studies in France are mainly used to answer to the request of our ministries in different fields. For example, the results of the second TDS were used in the update of the French food-based dietary guidelines, for the first time taking into account the contamination of the foods and not only the nutritional requirements. We also use the results to optimize the monitoring programs. Something like 2 years ago, the results were also used to prioritize through a ranking method and biological and chemical hazard to optimize the food safety and the risk management. The results were also used to model the effect on cadmium exposure of different scenarios of changing the regulation of cadmium in foods. So this type of work can be used by our ministries to defend the French position at the European level. We also use the result to assess the risk and the benefit of breastfeeding in France. And all our results are also commonly used in different national and European research projects. So, for example, in the TDS exposure project, of course, but also the project Euromix, and they will be used in the PARC consortium, the European Partnership for the Assessment of Risk from Chemicals. So the result of our total diet studies are also mainly used for assessing the cumulated and aggregated exposure. So cumulated exposure, I mean exposure to a lot of chemicals, because total diet studies provide results of numerous chemicals in the same food, because in the same food sample, this provides the possibility to identify the mixtures of chemicals to which the population is exposed. So we developed mathematical models to allow to identify clusters of individuals that have similar characteristics, so socio-demographical characteristics, for example, and to identify the mixtures of substances to which they are exposed that are relevant on a health basis, for example, with common ways of actions, and that are realistic regarding the exposure of the consumers. So we have different articles dealing with those results, and aggregated exposure. The results were also used to integrate the dietary exposure in the larger exposure through the different routes of exposure for relevant chemicals, of course, such as BPA, lead, phthalates, and so on. And there is also an example with this recent article that have assessed the exposure of young children to lead taking into account the different sources, food, dust, air, and water. The total diet studies in France are also a beneficial tool for our risk managers, of course, but also for the other researchers. That is why, apart from publication of the results, we also make the contamination results available for everybody, for the scientific community, but not only. The results are available for the second total diet study and the infant total diet study. The results are available in French on the French governmental website data.gouv.fr. But more recently, we also make the second TDS results available in English on the Zenodo platform of EFSA. So this is in open access. If you are interested, you can consult the results. So some take-home messages to conclude about the French total diet studies. So as I mentioned, the situation is considered tolerable or acceptable for more than 90% of the substances we have evaluated. For substances for which the risk cannot be excluded, we proposed some recommendations for management or also research measures. Total diet studies remain a major tool for ANSES, but also for the researchers, for our risk managers, our ministries, and that allow to follow trends in food contamination and exposure in France. Total diet studies also allow to give priority to food chemicals in order to help the risk manager in the public health policies and to adapt management measure and regulation, if any. And TDS also allow to inform the researchers on the priority research topics, such as lowering analytical limits. And I thank you for your attention, and I take the opportunity also to thank all my colleagues from ANSES, but not only, for their valuable contribution in all the French total diet studies.
Thank you very much, Véronique.